So in this demo we're going to look at generating the same grid pattern with triangles using WebGPU. Now this initial demo is just doing exactly the same as the OpenGL version did. However, there's no wireframe mode or anything like that because wireframe doesn't work like that in WebGPU. So same setup as before. We need to go through all the different stages of setting everything up. So again, initialize WebGPU, get a default device, initialize our buffers. So if we have a look at our buffers here, vertex data is calling create triangle plane. You'll notice this one's called triangle plane vectorized. The reason for that is I've jigged this to use NumPy and vectorized NumPy operations. So basically we are generating now an array with position, normal, UV in it. We then go through and use the linspace operations to generate evenly spaced X and Z coordinates, and the same for U and V coordinates. So linspace will sort of just auto generate that for us. Also notice the UVs in V now go from 1 to 0 just because of the differences in how UV mapping works with WebGPU as opposed to OpenGL and things like that. Then the mesh grid function within NumPy will generate from an array, from some ranges of data here, a grid like structure of things, and then we're converting that into array and reshaping it and transposing it with a T. And what this is doing is basically generating a series of quads on this evenly spaced data here. Then from those quads we can go through and generate the triangle data by interleaving the data, and then finally we've got our entire set of data. We tile in the single normals that we've got there and return it. So this is most probably not as easy to read and understand as the previous version, which was a bit more algorithmic and step by step, but this will be very quick because it's using the NumPy operations. Once we've got that data, we just generate our vertex buffer, which we're going to pass into our pipeline. In the pipeline, we're opening up our triangle shader. This is more complex than previous because we, again, like the OpenGL version, now we have position, normal and UV being passed in. So we have input shader location 0, 1 and 2. So we need to reflect that now in our pipeline. So what you can see here is our pipeline now has the offsets of a float 32 at input 0, an offset of 12, an offset of 24. So that's the offset in bytes in the buffer, and this is the offset of the input of the shader as we can go through there. And our stride now is 8 components. So we have X, Y, Z, we have NX, NY, NZ, and we have UV. So 8 components multiplied by 4 because that's the size of the float as we go in there. Everything else here is the same as the pipeline we had previously. Uniform, again, exactly the same here. And the pipeline layout, again, as we had before, exactly the same layout. So there's no real differences apart from adding the extra data to our pipeline and the way that the data has been changed from our previous lines demo. The only other thing is now that our data is now a triangle list here for our primitive topology, as opposed to before it was a line list. And then when we draw, same operations as before. It's just a matter now that we draw the number of tri-vertices that we generated, which we counted when we generated our buffers there, and that will generate our overall system. So in theory we could just set that to be 12, and that should just draw a single triangle there, as you can see. And then as we add more of those, I say 12, 3. So if we do 6, we should get the first chunk of our quad, and so forth as we go through. So it's standard processes as we've had before. we divide that by 2. Hard divided by 2 because it's going to be an integer. Now you can see we've just got half the grid there as we go through. Now, as I mentioned, the real issue here is that there's no wireframe mode in WebGPU because it is inefficient. It's changing the pipeline under the hood. There's a number of ways of doing this. What we could do is we could create an index array of each of the individual triangles, draw it as a series of lines and generate it that way. Or another approach is that we can use a shader to do it. So this wireframe mode here, because it's aliasing slightly as we go through there, is using a shader parameter and a few extra uniforms passed to the shader. So one is line thickness, and now you can really see the effect of the wireframe in the shader as we go through. And I've got a toggle here which we enable on and off. So this is a bit more complex, and you can also see that we've got some Qt controls in there. So if we have a look at this demo here, so the first thing, this is a very different shader. The way the shader works is we have an array of barycentric coordinates for the different edges that we want to determine. And when we go into our fragment shader, we basically, so the vertex shader, depending, this is expecting everything to come in as triangles, so not individual triangles. So basically every input, I'm generating it as a modulus of 3. What we've got here is the vertex index, this VID, which is a built-in. So vertex 0 is 0, vertex 1, vertex 2, vertex 3. So as it gets each of the vertices as a new number. And what that's going to do is select either this coordinate, or this coordinate from this array. That gets passed on into the shader here. And we determine which edge we're against, and we can determine how far our current fragment is away from the edge. And then we use this smooth step, which is like a function that looks like, so a step function would be a hard drop like that, whereas a smooth step uses some form of curve to make it a bit smoother, to mix it. And what we're doing is we're mixing basically our background color, so our alpha, with the current color to give us either the background color or the surface color. So what we've had to do is enable alpha blending and a few other features. So this is far more advanced than the previous demo. So let's start. Here is our UI. So what we're doing is we're creating a widget to hold all of our controls. In this case, it's a checkbox and a slider. So this adds the checkbox through there, and it's just adding the widget. This is adding the slider, and it's adding the widget there. Now we need to grab the main window, which is the one that's got the Q image we used to render in. So we create a main layout now and a dummy layout for our control container, and then we combine them together. And what that does is it just adds the second one on top of the first one, so they merge together. So that's giving us our things there. Got a couple of slots there to handle our changes and our updates. And we are using the same create triangle plane as before. We have our buffers being initialized as before, creating the same render pipeline from the point of view of the shader entries, the input locations, same fragment shader now. However, we have new targets now in the fragment shader in form of, we're adding a blend mode. So the blend factor here is basically when we blend color and alpha, we are blending the source alpha with 1 minus the source alpha, and we're adding them together. And then with the alpha mode, we're taking a value of 1, and then we're generating 1 minus the source alpha. So this is basically the compositing operation that's using when we blend with alpha. Now most of the time we disable this because it adds extra operations, but in this case we're using it to give us the wireframe for the transparency. Everything else, the depth compare function, so when we're comparing now, we're comparing with less so that we put pixels over the other. And now we've got more data here. So the first thing is we had MVP before, and that's a float 32. Now we've got line width and is wireframe. Both of these are single float values, and because that's going to be 16 plus 8 there, we need to round up our data to add 2 more floats so that it fits within the size of a vec4. Otherwise it struggles to get this data in there. So line width is being read in the uniform in this shader here. So we've got the uniform block now. So what we've got here is params. So params.y is going to match up this vec2 first component, the x, which is line width, and then params.y is going to match up with the second vec2, which is going to be wireframe. And then the other 2 components here are just padding. They're not used, but they need to be there. So we have to be careful when we're copying data across now. We have to sort of go through. Now I'm just accessing it called params.x, params.y. Most probably would be better off is extracting that as a proper name later and doing something in the shaders to make it a bit more readable. But we'll do it that way for now. Create the buffers, create all the binding as usual. And the painting is exactly the same as before. This is exactly the same as before. It's just that now there's a bit more complications that every time we make a change to one of these parameters, these get adjusted as well. So it's quite a quick and easy way of doing simple wireframe. As you can see, it works relatively well. It's useful for debugging. It's not the sort of thing you have for sort of production rendering or anything like that, but it is useful for quick visualizations and so on.